Today, in this video, we will see numerical on rectangular bar subjected to triaxial loading. Numerical is a bar of steel is 40 mm by 40 mm in cross section and is 120 mm long. It is subjected to a tensile load of 200 kN along the longitudinal axis and tensile load of 500 kN and 400 kN on lateral faces as shown in figure. Take modulus of elasticity E is equal to 210 GPa and Poisson's ratio 0.3. Find A. The change in dimension of bar. B. Change in volume of bar. C. Axial tensile longitudinal load acting alone can produce same longitudinal strain. So step by step we will see this numerical. First, given data. Load acting on longitudinal axis Px is equal to 200 kilonewton. This is x-axis, y-axis and z-axis. Load acting on lateral faces Py is equal to 400 kilonewton. Load acting on z-axis 500 kilonewton. Length of this rectangular bar capital L is equal to 120 mm. Breadth of this rectangular bar B 40 mm. Thickness 40 mm. Modulus of elasticity capital E is equal to 210 gigapascal. Poisson's ratio denoted by mu is equal to 0.3. And to find change in dimension of bar, A. Change in dimension of bar, that means this: change in length, change in breadth and change in thickness. Change in length, change in breadth and change in thickness. B. Change in volume. And C. Axial tensile load acting alone can produce same longitudinal strain. Load Px. Now solution. Step 1. Finding stresses in each direction. Stress in x direction. Stress is load upon area. And load in x direction is 200 kilonewton. Load in x direction divided by area. And this C is axial tensile longitudinal load acting alone can produce same longitudinal strain. That means this Px is difference. acting alone. Okay, this Px is 200 kilonewton. 200 into 10 raised to 3 Newton divided by area. This 200 kilonewton load acting on this 40 into 40, 40 by 40 mm square cross sectional area. Two hundred into 10 raised to 3 divided by 40 into 40, 125 MPa. Now stress in y direction, Py upon area. Stress in y direction is 400 kilonewton. 400 into 10 raised to 3 divided by this 400 kilonewton load acting on 120 mm length and 40 mm breadth. 120 into 40, area is 120 into 40 is equal to 400 into 10 raised to 3 divided by 120 into 40. 83.34 MPa. Stress in Z direction is load in Z direction divided by cross sectional area. Load in Z direction is 500 kilonewton and cross sectional area is this 120 length and 40 mm thickness. Five hundred into 10 raised to 3 divided by 120 into 40. 104.17 MPa. Sigma x, sigma y, sigma z are stresses in each direction for rectangular bar subjected to triaxial loading. Now, next step 2. Step 2 is strain in each direction. First, strain in x direction. Formula for strain in x direction is Ex is equal to 1 upon Young's modulus in bracket sigma x minus Poisson's ratio in bracket sigma y plus stress in y direction plus stress in z direction. This is formula for stress in x direction. 1 upon Young's modulus is 210. 210 into 10 raised to 3 MPa. Stress in x direction we calculate in step 1. Stress in x direction is 125 MPa minus Poisson's ratio is 0.3. Stress in y direction is 83.34 MPa and stress in Z direction is 104.17. Stress in Y direction is 83.34 MPa plus 104.17 MPa. Now calculate 83.34 plus 3.274 into 10 raised to minus 4. Strain in X direction is 3.274 into 10 raised to minus 4. Now next, strain in Y direction. Strain is denoted by E and Y direction EY is equal to 1 upon Young's modulus in bracket stress in Y direction minus Poisson's ratio multiply by in bracket stress in X direction plus stress in Z direction. 1 upon Young's modulus is 210 into 10 raised to 3 in bracket stress in Y direction is 83.34 minus Poisson's ratio is 0.3 into stress in X direction is 125 plus stress in Z direction is 104.17. 6.947 into 10 raised to minus 5. Strain in Y direction. Next, strain in Z direction. One 125 plus 83.34 multiplied by 0.3 10.17 minus answer into 1 upon 210 into 10 raised to 3 1.984 into 10 raised to minus 4. Strain in each direction. Strain in x direction is 3.274 into 10 raised to minus 4. Strain in y direction is 6.947 into 10 raised to minus 5. And strain in z direction is 1.984 into 10 raised to minus 4. Now next step 3. Step 3 is volumetric strain. Volumetric strain of a rectangular bar subjected to triaxial loading. EV is equal to EX plus EY plus EZ. EV is equal to EX is 3.274 into 10 raised to minus 4 plus EY 6.947 into 10 raised to minus 5 plus EZ 1.984 into 10 raised to minus 4. Three point two seven four into 10 raised to minus 4 plus 6.947 into 10 raised to minus 5 plus 1.984 into 10 raised to minus 4. 5.95 into 10 raised to minus 4 is volumetric strain. Next step is change in length. Find A first the change in dimension of the bar, and change in dimension of the bar is change in length, change in breadth and change in thickness. So calculate change in length. For calculation of change in length, strain in x direction is change in length to the original length. Therefore, change in length is equal to strain in x direction multiplied by original length. Strain in x direction is 3.274 into 10 raised to minus 4 and original length of that rectangular bar is 120 mm. So change in length is 3.274 into 10 raised to minus 4 into 120. 0.03928 mm. This is change in length. Next, calculation of change in breadth. Change in breadth or change in width. For calculation of change in width, same. Ez is equal to so this is width 40 mm. For calculation of change in width, use formula strain in z direction. Strain in z direction is equal to change in width to the original width. Change in width is equal to strain in z direction multiplied by original width. Strain in z direction is 1.984 into 10 raised to minus 4. And width is 40 mm. 0.0079 mm. This is change in width. Next, change in thickness. Change in thickness. For calculation of change in thickness, use formula strain in y direction, and strain in y direction is change in thickness to the original thickness. Therefore, change in thickness is equal to strain in y direction multiplied by original thickness. Strain in y direction is 6.947 into 10 raised to minus 5. Multiplied by thickness is 40. 0.0028 m change in thickness. So our finding of A is complete. Change in dimension of bar. We calculate change in length, change in breadth, and change in thickness. So change in length, change in width, and change in thickness. Change in thickness is 0.0028 mm. Change in width is 0.0079 mm. And change in length is 0.03928 mm. Next, calculate change in volume. Change in volume delta V. For calculation of change in volume, use formula EV strain in volume is equal to change in volume upon original volume. Therefore, change in volume is equal to EV into original volume, and EV is 5.95 into 10 raised to minus 4. into and original volume of that rectangular bar is length into width into thickness 120 into 40 into 40. Therefore, change in volume is 5.95 into 10 raised to minus 4 into 120 into 40 into 40. 114.2 mm cube. This is change in volume for that rectangular bar subjected to triaxial loading. Next, C is axial tensile longitudinal load acting alone can produce same longitudinal strain. To find new load in x direction, let P is the longitudinal load alone So for finding this new load in x direction, let P is the longitudinal axial load alone which can produce the same longitudinal strain as above. Axial tensile longitudinal load acting alone can produce same longitudinal strain. For finding this, we use Young's modulus formula. Young's modulus is stress upon strain and strain is stress upon Young's modulus. So strain in x direction is stress upon modulus of elasticity and stress is load upon area P upon A equal to E. Here stress is load upon area. Strain in x direction. So put values in this equation. Strain in x direction, same longitudinal strain as above. So strain in x direction is three 3.274 into 10 raised to minus 4. Equal to P divided by area is for that longitudinal load. Area is this 40 thickness and 40 width. 4t cross 4t, and Young's modulus is 210 into 10 raised to 3 MPa. Now calculate P from this equation. P is equal to 3.274 into 10 raised to minus 4 is equal to P upon 40 into 40 into 210 into 10 raised to 3. 110 kilonewton. This is load acting along x direction. Steel rectangular bar of length 120 mm, thickness 40 mm and width 40 mm. Longitudinal load along x direction is 200 kilonewton and lateral load along y direction and z direction are 400 kilonewton and 500 kilonewton respectively. We have to find change in dimension of this bar. Change in dimension means change in length, change in width, and change in thickness. So, change in length is 0.03928 mm, change in width is 0.0079 mm, and change in thickness is 0.0028 mm. Observe, this change in length is bigger value as compared to change in thickness and change in width, because length is 120 mm and width and thicknesses are 40 mm. Length is bigger, so change in length also comes bigger as compared to this width and thickness. Next, change in volume. Original volume of this rectangular bar subjected to triaxial load is 120 into 40 into 40, 1,92,000, and change in 1,92,000 mm3. This is original volume of this rectangular bar subjected to triaxial loading, and change in volume for this rectangular bar subjected to triaxial loading is 114.2 mm3. That means very small as compared to this original volume. And in C, numerical, they ask us axial tensile longitudinal load acting alone can produce same longitudinal strain. For that, axial tensile load is 110 kilonewton acting alone for that same strain in x direction 3.274 into 10 raised to minus 4. So this numerical completes. Thank you very much.